Hello and welcome back. Alright, in this video we are going to be taking a look at how we create user data types. Up until this point we've been using all the types that are built into the C++ language like integer and double. But we actually haven't been able to create our own custom types. So let's say we wanted to create a two-dimensional point where it has x and y as components of that variable. Well, we haven't learned how to do that. So let's go ahead and do that. Okay, so in C++, the way we do this is with the special keyword called struct. And now we have to give the struct some sort of name so that we can reference it. And we're going to call it point because we're going to create that two-dimensional point that I talked about. And then we do a open curly brace, then we do int x, int y, because it's made up of 2 points, end curly brace, and semicolon. And so that's really all we do to define a new point. There's the member fields, our 2 variables within our point, and we have the special word struct, which is going to tell us that, hey, everything in here should be grouped into whatever we named it. We named it point, so whenever we deal with points now, this is always going to have 2 components, an x and a y. Let's go ahead and take a look at how we use this now. So whenever we declared a normal variable, like an integer, all we did was int x, and that defined us a new variable. Well, the same thing for our custom data types. We do the exact same thing. We do point p, and we have a new point. So now, how do we actually access the member fields, the x and y, inside of our point? Well, we use the special dot operator, which is a period. So you do the name of your structure variable, in this case, is p. It's of type point, so we know that it's going to have an x and a y field. And then you just do the name of the item, or of the member that you wish to assign or get a data from. So we're going to do point.x equals 1, and we'll do point.y equals 2. All right. And now we have set our pointer, or our new point class, and we've initialized the x component to 1 and the y component to 2. And we could print this out. We'll do parenthesis p.x, p.y, and line. We forgot our closing parenthesis. All right, if I build this and run it, we'll see, oh, we got our point printed out, 1, 2. And really, that's all there is to defining a point. Now we know how to work with a point if we have a normal variable here. But what if we had a pointer to one of these data types? So how would we define that? Well, we do it just like we do a pointer to any other variable type. We'll do point, the name of the structure that we want. We'll do the star, and then we'll call this pointer. All right, so how do we actually access this data? Well, let's draw what we have in memory so far. We have created a struct. It has 2 components. It has x and it has y. And p is this block, or this complete block. Now we have let's just do this point p. Okay, and now we have this pointer p. All right, so we know that all pointers, this pointer is ptr. We know that all pointers need an address, so let's go ahead and assign the address of p into pointer. Let's jump back over into Xcode. So we'll say ptr equals the address of p. All right, so if we go back to our whiteboard, now we know that pointer is either a 4-bit integer. Remember that all pointer types are the same. So this is either 4 bits or 8 bytes, or 4 bytes or 8 bytes, depending on your system. It now has the address of this block. Perfect. So now we have pointer pointing to the right spot. Now how do we access the data there? Well, just like with any other pointer, we need to dereference it to follow this chain. So let's go back over to Xcode. If I want to print out the same thing, let's copy and paste this line. We need PTR here and PTR there. Well, I need to dereference it. So if I do this, let's see what happens. We get 2 errors. And the problem is that if you do this, the dot operator actually has a higher precedence than your dereference operator, this star. So what we need to do is we need to enclose this whole thing, the star PTR, within parentheses. Now if we rebuild it, we can see that, hey, everything compiled. Let's see if we get the same answer. 1, 2, 1, 2. Perfect. So let's jump over the memory diagram here just to make sure that we know what we're doing. So when I do star PTR, I'm following this chain, or this arrow, all the way to this memory. And now that we do star PTR, this is equivalent to accessing our normal P variable that we had. And so in order to access the data off of that, we use the dot operator and the X or Y to gain access to the appropriate field. Well, there's also one other way that we can do this. As you can see, putting this in parentheses each time is going to be a little tedious. And so there's a little cleaner syntax that we can use. So let's copy and paste this line down here. So instead of using the parentheses and the star, we can do this. We can delete that, and we won't use the dot this time. Instead, we're going to use this arrow operator. And this is a hyphen and the less than symbol, or greater than symbol, sorry. It's the hyphen and the greater than symbol. And so we'll jump over here and change this over. If we build this and we run it, we see that we get the same output. So what does this do? Well, the arrow operator, let's jump over to our diagram, does the exact same thing as this. So if we had star PTR dot X, the arrow operator is the same thing. And this just allows us to write our code a little bit cleaner. A little less keystrokes that we need to do, and the semantics are all captured right here when we want to grab the member field, instead of being kind of interlaced between the type in 3 different spots. So either way is perfectly fine. You can do star PTR, or you can do the arrow to access fields off of your pointer types. Totally up to you. Okay, so we've learned about how to access those data fields. How do we pass in a point to a function? So let's say we wanted to convert this entire line into a function called print point. So we'll create a new function, no return type. We'll call it print point, and we'll pass in a new point. And then we will just copy and paste this in there, and we will replace each of these lines. Well, let's replace the first line first. So we'll do it right above it. So we'll do print point, and we'll pass in P. That's great. Then we'll do print point, and we'll pass in star PTR. And I'm going to actually leave this last line right there. So let's rebuild. We can see that we actually built correctly. So let's actually talk about this one right here. So in this one, we needed to pass in a point. A point is expected as our function type. Well, we have a star PTR, so this will convert it back down to P. Jump back over into our box. Remember that star PTR is going to give you the equivalent of the P field, or of the P variable. Let's get rid of that to make it more clear. So start PTR is equivalent to P because we travel down the memory arrow and we get the memory address at P. And so now we have the P guy. Okay, perfect. What we can't do is this. We can't do the star arrow because we've already done that in here, and we already knew that PTR arrow is the same as dereferencing PTR first. So we can go ahead and get rid of that line. All right, if we come over here and run, we can see that everything did indeed happen. And with that, that's going to wrap up this video. Thanks.